Question 1. Given that 2 to the power of x times 4 to the power of y is equal to 1 over 2 root 2, express y as a function of x. So we're looking for y equals something to do with x. And we've got powers of 2 here. So 2 to the power of x times 4 to the power of y. 4 is the same as 2 squared. So we can change 4 into 2 squared. So 2 squared to the power of y is the same as 2 to the power of 2y. And that's equal to 1 over 2 root 2. So I'll do this in steps. 2 is 2 to the power of 1. Root 2 is 2 to the power of a half. And when we multiply, we add the powers. So on the left, we've got 2 to the power of x plus 2y. And on the right, we've got, I'll leave the 1 over there for now, 1 over, and we've got 1 plus a half, which is 1.5 or 3 over 2. And when we've got 1 over, flipping is the same as having a negative power. So 1 over 2 to the power of 3 over 2 is the same as 2 to the power of negative 3 over 2. So we've got a power of 2 on the left, a power of 2 on the right. So the two powers must be equal. So x plus 2y must be equal to negative 3 over 2. We need to get y by itself. So we will take x away from both sides. And then half everything. So divide everything by 2. So that would be negative 3/4 minus x over 2. And there we have our answer. Y is a function of x. Question 2. The speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. The results are shown in the table below, with the time in seconds and the speed in meters per second. Using this information, estimate the length of runway used by the jet to take off. So we've got a velocity time graph here, speed time graph. So the distance traveled is the area under the graph. And to find the area under graph, we can use the trapezium rule. So we're going to use the trapezium rule here to work out the area under this graph. So one way of doing that is to half the first one and the last one. So we'll have 2 over 2 plus 5 plus 10 plus 18 plus 28 plus 42 over 2. So half the first one, the last one, leave the rest as they are, and multiply by the gap between each one. So it's going up by 5 every time. Our trapeziums are 5 wide. From 0 to 5 is 5. From 5 to 10 is 5. So we multiply by 5. So let's type this in the calculator. So we've got 2 over 2, which is 1, plus 5, plus 10, plus 18, plus 28, plus 42 over 2. All times by 5. So 415. So we've got 415. What's the length? It's in meters. So the units used were meters per second and seconds. So we've got meters as the distance. Part B, given that the jet accelerated smoothly in these 25 seconds, Explain whether your answer is an underestimate or an overestimate. So let's do a quick sketch here. So we've got accelerating smoothly, which will give us a curved line going up. Something like that. And we've used trapeziums to estimate. So there'll be straight lines to estimate the area. So our trapeziums, because it's curved going up, are going to have an area greater than the actual curve. There'll be areas under the trapeziums that aren't under the curve. So the area under the trapeziums is greater than the area under the curve. The area under the trapeziums is greater than the area under the curve. So it will be an overestimate. It's an overestimate. Question 3. So here we've got figure 1 showing a sector AOB, center O, radius 5 centimeters, and angle AOB is 40 degrees. The attempt of a student to find the area of the sector is shown below. So we've got area of a sector equals half r squared theta, and they've worked it out using 40 as theta. So explain the error for part A made by the student. They've used a formula that only works for radians. So they've used 40 degrees, but this formula only works for radians. So we can say half r squared theta only works when the angle is in radians. So for an angle in degrees, we can use theta over 360 times pi r squared. And we need to write out the correct solution. So the area is theta, which is 40 over 360 times pi times the radius, which is 5 squared. So let's type that in the calculator. So 40 over 360 times pi times the radius squared. And we've got 25 over 9 pi. 25 over 9 pi. And the units are centimeters squared. Question 4. So we've got figure 2 here. We've got curve C1 with parametric equations x equals 10 cos t and y equals 4 root 2 sine t, where t is between 0 and 2 pi. And we've got a circle C with equation x squared plus y squared equals 66. So there are 4. So they meet each other at 4 points, as shown on the diagram. And one of the points is S. And we need to find the Cartesian coordinates of S. So the two curves, the curve meets the circle where both equations are equal. So we can substitute 10 cos t in for x. 4 root 2 sine t in for y, then it'll all be in terms of t, and the solutions will be where it meets. So let's do that. So we've got 10 cos t squared. So I'll just write that 10 cos t squared plus 4 root 2 sine t squared. 4 root 2 sine t squared equals 66. So let's square these. So 10 cos t squared. 10 squared is 100. Cos t squared is cos squared t. 4 root 2 squared. So we can check this on the calculator, but that will be 16 times 2, which is 32, sine squared t, and it's equal to 66. So we've got a cos squared t and a sine squared t. We can get rid of one of them using cos squared t plus sine squared t equals 1. So it doesn't matter which one we get rid of. Let's take sine. Let's get sine by itself. So take cos squared t away from both sides. So sine squared t is 1 minus cos squared t. So we can substitute this in. So we've got 100 cos squared t plus 32 times 1 minus cos squared t equals 66. Expanding this bracket, so we've still got 100 cos squared t. We've got 32 minus 32 cos squared t equals 66. So 100 minus 32 will be 68. So we've got 68 cos squared t's. And 66 minus 32 will be 34. So dividing both sides by 68 gives us cos squared t is equal to 1/2. And cos t will be plus or minus the square root of 1/2. So let's grab a calculator. Shift cos root 1/2 is 1/4 pi. Or shift cos the negative root of 1/2 is 3/4 pi. Let's get the other answers for these. So we want all the answers up to 2 pi. It's cos, so it would be 2 pi, so 360 degrees minus the first answer. So 2 pi minus the first answer. 2 pi minus 1/4 pi, so is 7/4 pi. 8/4 minus 1/4 is 7/4. And 8/4 minus 3/4 is 5/4. So there are 4 t values we've got. We want to know the coordinates of S. So we just need to substitute these t values in for x and y and to see the coordinates of both of them. So let's just substitute in. So we've got all 4 answers here. We don't really know which one is going to give us S. So one of these t values will give us a positive x and a negative y. So we're just going to have to substitute in and see. So we've got 1/4 pi. Oh, start with 1/4 pi. 1/4 pi 10 cos t. So store that as a 10 cos a is 5 root 2. Get 5 root 2. And 4 root 2 sine t is 4. So that's not the one we want. That is this one here. So positive x, positive y. Now, which other one will give us a positive? Cos. Let's try the 7 over 4 pi. So 7 over 4 pi. When t is 7 over 4 pi. So store that in the calculator. I've stored it as b. 10 cos t is 5 root 2. And 4 root 2 sine t is negative 4. So that is the point S. It's got a positive x and negative y. So it's 5 root 2, negative 4. Question 5. So figure 3 shows a sketch of the curve of equation y equals root x. The point P with coordinates x, y lies on the curve. The rectangle shown shaded as a height of y and a width of delta x. Calculate, so the limit as delta x gets closer to 0, so as this gap gets closer to 0, the sum of all the root x's times delta x's, so the sum of all of these rectangles here, between 4 and 9. So it is saying find the area under the curve between 4 and 9. And we do that using integration. So it's just the notation they've used here looks a lot different to what we usually see. It's the same as the area between 4 and 9 of root x with respect to x. That's what we're working out. And you can actually just put this in the calculator. So if you're using one of these calculators, we've got the integration button here. So root, and we'll go with alpha x between 4 and 9. And it's come up with 38 over 3. 38 over 3, and I've just put units squared. Question 6. So we have figure 4 here, and it's a sketch of the graph y equals g of x, where g of x is x minus 2 squared plus 1 when x is less than or equal to 2, and when x is bigger than 2, g of x is 4x minus 7. So we've got two different parts to the graph, one when x is bigger than 2 and one when it's less than or equal to 2. And part A says find the value of g of g of 0. So we're going to put 0 into the function, and then the answer we get out from that we're going to put into the function again. So let's do g of 0 first. So g of 0. So 0 is less than 2. So we'll use the top equation. So we've got 0 minus 2 squared plus 1. Negative 2 squared is 4, plus 1 is 5. And we're going to put 5 in now. We use the bottom one now. X is now bigger than 2. So it's 4x minus 7. 4 5s minus 7. 4 5s are 20. 20 minus 7 is 13. Part B. Find all values of x for which g of x is bigger than 28. So let's say 28's up here somewhere. So we're going to get one answer on our quadratic part of the graph and one answer over here for the linear part of the graph. So we're going to have to use both of these, and we want to know where they're bigger than 28. So we've got, for part B, x minus 2 squared plus 1. We want to know where that's bigger than 28. And we want to know where 4x minus 7 is bigger than 28. So the linear part is going to be easier. Let's do that first. So plus 7 to both sides. 28 plus 7 is 35. And then divide both sides by 4. So x is bigger than 35 over 4. For our quadratic one, to solve a quadratic, we make it equal to 0. So we're going to expand these brackets first. X minus 2 times x minus 2 plus 1 is bigger than 28. So I'm going to expand x minus 2 times x minus 2. So x squared minus 2x minus 2x plus 4. And we've got plus 1 is bigger than 28. So we've got x squared minus 4x plus 5 is bigger than 28. We want to make it equal to 0. So let's take 28 away from both sides. X squared minus 4x minus 23 is bigger than 0. To solve this, we can use our calculator. So let's grab the calculator. We want to go into the menu, and then we'll go down to this B1 here. So it's inequalities. So we want inequalities. We've got a polynomial degree 2. It's a quadratic. And we want ax squared plus bx plus c is bigger than 0. So that's number 1. We've got 1x squared minus 4x's minus 23. Press equals, and we get our answer. So x is less than 2 minus 3 root 3. Or x is bigger than 2 plus 3 root 3. Now we only want one of these answers. We're only interested in the answer on the negative side of the graph. We don't want the answer bigger than, what was it, bigger than 2. Anything bigger than 2 we're not interested in. So 2 plus 3 root 3 is bigger than 2. So we reject that one. And we just want these two. So x is less than 2 minus 3 root 3. Or x is bigger than 35 over 4. That's our answer. There is a part C. So function h is defined by h of x equals x minus 2 squared plus 1, where x is less than or equal to 2. So it's the same as this part of g of x. I'll explain why h has an inverse but g does not. So this part of the graph here has an inverse because it's a one-to-one function. One-to-one functions have an inverse, and many-to-one functions don't have an inverse. So we can just say h is a one-to-one function. So has an inverse. And g of x is a many-to-one function. So does not have an inverse. And part D says solve the equation. So we want to know whether the inverse function of h is equal to minus a half. So the output of the inverse function is minus a half. But with an inverse function, the output becomes the input and the input becomes the output. So the output of the inverse function is the same as the input for the original function. So what we can do, we can put this in to the original function, and that output will be the answer to this question. So let's just substitute this in. So we want minus a half minus 2 squared plus 1. So minus a half minus 2 all squared plus 1. So minus a half minus 2 is minus 2.5, or minus 5 over 2. We want to square minus 5 over 2. So 5 5s are 25, 2 2s are 4. We could have used, of course, used a calculator here. And we've got 25 over 4 plus 4 over 4, which is 29 over 4. Question 7. A small factory makes bars of soap. On any day, the total cost to the factory, Y pounds, of making X bars of soap is modelled to be the sum of two separate elements. We've got a fixed cost and a cost proportional to the number of bars made. Write down a general equation linking Y and X for this model. So Y, the cost, is something proportional to the number of bars of soap made, which is X. I think I'm just going to write MX plus C. So something proportional to the number made plus a fixed cost. So Y equals MX plus C. You can use different letters for M and C, but it's going to be something like that. So the bars of soap are sold for £2 each. On a day where 800 bars of soap are made, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Use the above information to show that Y equals 0.84x plus 428. So let's write part B. So this number of bars of soap, that was X. So when X is 800, the profit, so that's something new we've got to add in, is £500. And when X is 300, the profit, well, is negative £80. So the profit is, well, the cost of how much they make minus how much they cost to make. So the profit is how much they make from selling them. So £2 each, 800 bars, that's £1,600. They get £1,600 in, and to make it, it costs this. So M times 800, or 800M, plus C. And that is 500. It's a profit of 500. And when they sell 300, that gets them 300 times 2, so £600. It costs 300M plus C to make. So that's the cost of production, and that is negative 80. So we can use these two equations. They're simultaneous equations. If we solve them, we will find M and C, which is what we want. So let's simplify these a little bit. So for the top one, we've got 1,600 minus 800M minus C equals 500. And let's bring the 800M and the C to the other side. So take 500 away from both sides. So that's 1,100. And add 800M and add C to both sides. For the second one, we've got 600 minus 300M minus C equals negative 80. So again, let's add 80 to both sides. So that's 680, and that's equal to 300M plus C. So here we've got two equations with two unknowns. There are simultaneous equations. We're going to solve them. So 1,100 equals 800M plus C. And 680 equals 300M plus C. So let's take away, so top equation minus bottom equation. So that leaves us with 420 equals 500M. So the C's cancel out. 800 minus 300 is 500. 1,100 minus 680 is 420. So to find M, just divide both sides by 500. So 420, go back to the normal mode. 420 over 500 is 21 over 25, or 0.84. And I think that's what we wanted. I think we wanted 0.84. And then let's find C. So let's substitute the M back in. So 680 equals 300 times 0.84 plus C. 680 minus 300 times 0.84 is 428, which again is what we wanted. So we've got y equals 0.84x plus 428. With reference to the model, interpret the significance of the value 0.84 in the equation. So that is the cost that is proportional to the number of bars of soap made that day. So that's the cost of the variable part of the cost of producing 1 bar of soap. So part C, I think. So it's the put variable cost of producing each extra bar of soap. Assuming that each bar of soap is sold on the day it's made, find the least number of bars of soap that must be made for the factory to make a profit. So we're back to using this. So it's 2 times the number of bars sold, so 2x. That's how much money they make, 2 times x, minus how much it costs to make them, which is 0.84x plus 428. So that's how much they make, that's how much it costs to make them, and we want to know when it's 0, do we? So let's say if they're making a profit, that's got to be bigger than 0. So I'm going to use an inequality here. So where is it bigger than 0? So we want to make a profit. So the money they make, take away the money it costs, has to be bigger than 0. So let's solve this. We've got 2x minus 0.84x minus 428 is bigger than 0. So 2 minus 0.84 is 1.16. And if I add 428 to both sides, I want to know x. So divide both sides by 1.16. And that's 368.96. So x has to be bigger than 368.9 and so on. So how many bars of soap do they need to make? Well, it has to be bigger than this. So 369 bars of soap. 369 bars of soap. Question 8. So we've got find the value of, and we've got a sum starting up when r is 4, going up to infinity. So it's a sum to infinity, and the formula to find each term is here. So we're going to use our geometric sequence formula. So let's start with part I. So the first term is when r is 4. So that will be 20 times half to the power of 4. Let's figure out what that is. So 20 times a half to the power of 4. That's our first term. It's 5 over 4. So that is our A. That's our first term. And, well, I guess R is a half, but let's just check this. So 20 times a half to the power of 5 is 5 over 8. So it's half as much. So R is a half. So the sum to infinity is A over 1 minus R. So it's going to be 5/8 over 1 minus a half. So let's type that in the calculator. So we've got 5/8 over 1 minus a half. And that's 5 over 4. No, 5 over 4 was our A. Let's change that to 5 over 4. 5 over 4 is A. So A over 1 minus R. And that's 5 over 2. Okay, so the second part, we've got show that. We've got the sum, again, from 1 to 48. So starting when n is 1, going up to when n is 48, of log 5 n plus 2 over n plus 1 is equal to 2. So we've got log base 5 n plus 2 over n plus 1. If we use the rule of logs, we say log 5 n plus 2 minus, so divide is the same as a minus, log 5 n plus 1. And we want to add up all the terms from when n is 48. So 48, 47, 46, 45, 44, and all the way down to 1. So we've got a lot of numbers to add up here. But where we're going to be doing this taking away, we're going to cancel some out. So the biggest number will be when n is 48. So if we have log 5 48 plus 2, that would be log 5 50 minus log 5 48 plus 1, which is 49. Then we're going to add on. So let's do 47 next. Log 5 47 plus 2 will be log 5 49. Take away log 5 47 plus 1 will be 48. And see, these 49s are going to cancel. So, and this pattern's going to keep going. So let's do the next one. So 46. So log 5 46 plus 2 will be our 48. So they cancel. Plus log 5 47. And then we'll take away log 5 47. So we'll keep taking away. So all these two are going to cancel. These two are going to cancel. We'll have this one next. These two are going to cancel. And so they're all going to cancel, apart from the very last one, which will be log 5. So let's start with let's start a few before the end. So let's start with 2. So when n is 2, we'll have log 5 4, which would have already cancelled with the one before it, minus log 5 3. And then when it's 1, log 5 3 minus log 5 2. So all we've actually got left is log 5 50, take away log 5 2. Log 5 50 minus log 5 2 is the same as log 5 50 divided by 2, which is log 5 25, and 5 squared is 25, so log 5 25, so log 5 base 5 25 is equal to 2. Question 9. A research engineer is testing the effectiveness of the braking system of a car when it's driven in wet conditions. The engineer measures and records the braking distance d meters when the brakes are applied from a speed of v kilometers per hour. Graphs of d against v and log 10d against log 10v were plotted. The results are shown below together with a data point from each graph. So we've got figure 5 and figure 6 here. We've got the graph of the d, the distance, against v, the velocity, the speed, and log 10d against log 10v. And part A, explain how figure 6 would lead the engineer to believe that the braking distance should be modeled by the formula d equals kv to the power of n, where k and n are constants, with k approximately equal to 0.017. So let's take this one. Let's take what we're given here. So d equals k times v to the power of n. And let's try and relate it to figure 6. So if we log both sides, so log base 10, so we'll have log 10, so log 10d equals log 10 kv to the power of n. We can think of log 10 kv to the power of n as log 10k plus, so that it's multiplied together at the moment. K is multiplied by v to the power of n, so we can change that to a plus. So log 10k plus log 10 v to the power of n. And when we've got a power here, it can jump down to the front. So log 10v to the power of n is the same as n times log 10v. So let's move to the new page. So log 10d equals log 10k plus n times log 10v. And this is like y equals mx plus c, isn't it? So log 10d is our y, log 10v is our x, and it's got a y-intercept of a y-intercept of minus 1.77. So n is our gradient, so n would be the gradient, and log 10k would be the y-intercept. So log 10k is the y-intercept, which is at negative 1.77. And so we can use this to find k. So the base is 10, the power is negative 1.77, and that equals k. So 10 to the power of negative 1.77 is 0.01698. And it said approximately equal to 0.017. So approximately equal to 0.017. Part B. Find a complete equation for the model given the value of n to 3 significant figures. So let's find n. Either one's fine. Let's use this. So d equals kv to the power of n. D equals kv to the power of n. And we know k is 0.017. And if we use the first graph, we know when v is 30, d is 20. So x, y, v is 30, d is 20. So 20 equals 0.017 times 30 to the power of n. So let's solve this. So divide both sides by 0.017. So 20,000 over 17 equals 30 to the power of n. So we want to find n, so we can use logs. So n is equal to log 30 20,000 over 17. So log 30 answer is 2.08. So find the complete equation for the model. So writing that out again, we've got d equals 0.017 v to the power of 2.08. And we've got part C. So Sean is driving at 60 kilometers per hour. Were we in kilometers per hour before? We were, yep. So that's V. In wet conditions, when he notices a large puddle in the road 100 meters ahead, it takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if Sean will be able to stop before reaching the puddle. So it takes him 0.8 seconds to react. So we need to know how far is left of the road before he actually applies the brakes. So how far do you go? 0.8 seconds at 60 kilometers per hour. So we go for 0.8 seconds at 60 kilometers per hour. So let's change kilometers per hour into kilometers per second. And to do that, so 1 hour is 3,600 seconds. So we're going to divide by 3,600. So 1/60th of a kilometer per second. So what's the distance? So the distance is going to be the speed times time. Speed equals distance over time, so distance equals speed times time. So that's 1/60th times 0.8. And that's, well, we're in kilometers, so 0.013 recurring kilometers, 1/75th of a kilometer. And D meters, let's work in meters. So 1/75th of a kilometer is how many meters? Multiply it by 1,000. 13.3 recurring meters. So how long is... So we had 100 meters of road left. In the time it took him to react, he's moved 13 meters. So 100 minus 13.3 recurring means he's got 86.6 recurring meters of road left. So that's when he applies the brakes, and then we can use our formula here. D equals 0.017 V to the power of 2.08. And the velocity, the speed he was going at, was 60 kilometers per hour. So 60 kilometers per hour, 0.017 times 60 to the power of 2.08. That's 84.9 meters. So he does stop in time. 84.9 is less than 86.6 recurring. So Sean stops on time. Just checking that was the question. Will he be able to stop before reaching the puddle? So yes. Question 10. So figure 7 shows a sketch of triangle OAB. The point C is such that O to C is equal to 2 O to A's. So that's why we've got space up here. So O to C is 2 lots of O to A. So C is up here. The point M is the midpoint of AB. The straight line through C and M cuts OB at the point N. So C and M cuts OB at the point N. Given that O to A is A, O to B is called B, so the whole of O to B is called B. Find C to M, and M is a midpoint in terms of A and B. So C to M, so we want to go C to A, and then half of A to B. So let's say A to B first. To get from A to B, we go minus A, backwards down an A, plus a B. So minus A plus B. And we're going to say that C to M is C to A, and then half of A to B. And C to A is a minus A, backwards along an A. And we've got half of A to B, which is minus A plus b. So we have minus a minus a half a plus half a b. So minus 1 minus another half is minus 1.5, or minus 3 over 2. So minus 3 over 2a plus half of a b. And b, show that O to n, so O to n is 2 minus 3 over 2 lambda a plus half lambda b, where lambda is a scalar constant. So O to n, from O to n. Okay, so O to n is, well, it's a fraction of b, but we can also say O to n is O to c, and then a multiple of c to m. So O to n is O to c plus a fraction. Should we call it lambda? Let's go for it. So a fraction of c to m, which is what we just worked out. So O to n is O to c, which is 2a's, plus a fraction of our previous answer, which was negative 3 over 2a plus half a b. So we have 2a, expanding this bracket, so minus 3 over 2 lambda a plus half a lambda b. And if we think of this as factorizing out the a, so we'll have 2 minus 3 over 2 lambda a plus half lambda b, which is what we wanted. That's our answer. Hence prove that O to n is 2 parts and n to b is 1 part. So we also know that O to n is a fraction of b. So O to n is a fraction of b, which means the A part must be 0. So 2 minus 3 over 2 lambda must equal 0. So we can find out lambda, so we'll plus our 3 over 2 lambda to both sides. Then we'll multiply by 2, divide by 3. So we get lambda is 4/3. So what is O to n? It is half times 4/3 b. Which is 4/6 b, which is the same as 2/3 b. So we had to prove that O to n is 2 parts and n to b is 1 part. So O to n is 2/3 of a b. O to b is a b. So O to n to O to b, O to n to n to b O to n is 2/3 b. N to b is, well, 1b minus 2/3 of a b, which is 1/3 of a b. So that's 2 to 1. Question 11. Figure 8 shows a sketch of the curve C with equation y equals x to the power of x, where x is bigger than 0. Find, by firstly taking logarithms, the x-coordinate of the turning point of C. So we've got y equals x to the power of x, and we're told the first step, take logarithms. So that's ln y equals ln x to the power of x. The x here is going to jump to the front. So we've got ln y equals x ln x. So we're differentiating. We are differentiating with respect to x. We want to find the turning point. So where dy dx equals 0. So let's differentiate this. Ln y differentiates to 1 over y. And because it's in terms of y, we put a dy dx after it. And here we've got a product rule. So we can say u is x, v is ln x, so du dx is 1, dv dx is ln x differentiates to 1 over x. So we're going to times these together and put a plus in the middle. So x times 1 over x is 1, and we've got 1 times ln x, which is ln x. The turning point is where dy dx is 0. So, well, 1 over y times 0 is 0. So we're left with 0 equals 1 plus ln x. So take 1 away from both sides. And we want x by itself. So this is log to the base ex. So e is the base, -1 is the power. So e to the power of -1 is equal to x. So e to the power of -1 is the x-coordinate of the turning point. And we only wanted the x-coordinate. So we're on to part B. The point P, A2, or alpha 2, A2, lies on C. Show that A is between 1.5 and 1.6. So we can substitute 1.5 and 1.6 in, and they should be 1 smaller than 2 and 1 bigger than 2. So y equals x to the power of x. Let's substitute in 1.5. And let's substitute in, it was 1.6. So 1.5 to the power of 1.5 is 1.837 and so on. 1.6 to the power of 1.6 is 2.121 and so on. So 1 is above. 1.837 is bigger than 2. No, it's not. 1.837 is less than 2, and 2.121 is bigger than 2. and it's a continuous function. Continuous function. Therefore, a is between 1.5 and 1.6. A possible iteration formula that could be used in an attempt to find a is xn plus 1 equals 2xn to the power of 1 minus xn. Using this formula with x1 equals 1.5, find x4 to 3 decimal places. So xn plus 1 equals 2xn to the power of 1 minus xn. Equals 2xn to the power of 1 minus xn. Let me just check that. 2xn to the power of 1 minus xn. x1 is 1.5. So x2 is going to be 2 1.5s to the power of 1 minus 1.5. So I'm going to put 1.5 into the calculator. So I've got 2 answers to the power of 1 minus the answer. So I've got 1.63. So we want x4. We're going to keep going. So 1.633 x3. Press equals again. 1.466 x4. 1.673 so there's x4. Describe the long-term behavior of xn. So let's see what happens if we keep pressing equals. 1.414, 1.732, right, so the long-term behavior is, well, this 1 2 1 2 1 2 1 2. So part D, describe the long-term behavior. So it goes 1 2 1 2 1 2. That's not really a description. So it's a periodic sequence. It's got a period of 2. Or we could say it's oscillating. Oscillating between 1 and 2. So either of those would be okay. Question 12. So part A, we need to prove that cos 3 theta over sine theta plus sine 3 theta over cos theta is equivalent to 2 cot 2 theta. So we're going to start with the left side of this identity, and we want to just rearrange it until we get the right side. So there'll be more than one way of doing it, but we're just going to rearrange until we get 2 cot 2 theta. Sine theta plus sine 3 theta over cos theta. So I'm going to start by adding the fractions together. So I don't know where it's going to go at the moment. I just know I don't want 2 separate fractions, so I'm going to add them together. So to add fractions, you need to make the denominator the same. So the denominator is going to be sine theta cos theta. So let's multiply top and bottom of cos 3 theta over sine theta by cos theta. So I have cos 3 theta cos theta over sine theta cos theta. And we'll multiply the top and bottom of sine 3 theta over cos theta by sine theta. So now the denominators are the same, we can add them. So we've got cos 3 theta cos theta plus sine 3 theta sine theta over sine theta cos theta. Now how can we simplify this again? We've got cos 3 theta cos theta plus sine 3 theta sine theta. And if we look at in the formula book, we can see that cos A minus B, so I'll write this in a different color. So cos A minus B is cos A cos B plus sine A sine B. And we can see how this relates to the numerator, the top of the fraction. So if A is 3 theta and B is theta, we've got, well, it's in this exact format. So we can change it into cos 3 theta minus theta. So we've got cos 3 theta minus theta over sine theta cos theta. Cos 3 theta minus theta is actually cos 2 theta. So cos 2 theta over sine theta cos theta. And we can also use our double angle formula for sine 2 theta. So we know sine 2 theta, sine 2a, is equal to 2 sine A cos A. So if we half both sides, we can say half of sine 2a is sine A cos A. So here we've got sine theta cos theta. We can change it into half sine 2 theta. So we've got cos 2 theta over half of sine 2 theta. Instead of dividing by a half, we can multiply by 2, or we can think of it as doubling the top and the bottom. So double the top and the bottom for 2 cos 2 theta over sine 2 theta. And cos over sine is cot. Sine over cos is tan. Cos over sine is cot. So it's 2 cot 2 theta. And 2 cot 2 theta. Hence, so using our answer, solve for 90 to 180 degrees the equation. So we know we don't need to write all of this because we're using our previous answer. So we can write 2 cot 2 theta equals 4. So we're solving 2 cot 2 theta equals 4. 2 cot 2 theta equals 4. So let's half both sides. Cot 2 theta equals 2. And we don't want to work with cot. We want to work with tan. So let's flip both sides. So that'll be tan 2 theta equals 1/2. So we're going to get 2 theta by doing shift tan, arc tan of a half. And we were in degrees, weren't we? So between 90 and 180 degrees. So let's make sure our calculator is in the right setting. So shift setup, angle unit, degrees. So it's shift tan of a half. So we've got 26.57. So So 26.57. And to find the next answer, we're in 10. We're going to keep adding 180 degrees. So plus 180, 206.57. And we'll add 180 again. So that's going to be one of our answers when we half it. I'm going to store it as A. I'm going to add 180 again. 386.57. And I'll store that as B. Do we need any more? So when we half these, they're going to be bigger than 180 degrees. So the only one we actually want is this 206. So we stored it as A, divide it by 2, so 103.3. Question 13. So here we have a storage tank. The tank is modelled in the shape of a hollow circular cylinder closed at one end and a hemispherical shell at the other, as shown in figure 9. The walls of the tank are assumed to have negligible thickness. The cylinder has a radius r, height h, hemisphere, radius r. The volume is 6 meters cubed. Show the surface area of the tank in meters squared is given by this formula. So we need to find the surface area of these two shapes and add them together. So let's start with that. We're also going to be using this information about the volume, probably to eliminate the h. So let's go with the volume first. Let's start with the volume. So the volume is going to be pi r squared h for the cylinder and the hemisphere. So this is a sphere, so a hemisphere is half of this, so 2/3 pi r cubed. So that's the volume, and we know r is, no, we don't know r is r. We know V is 6, and that's all we know. So we've got 6 equals pi r squared h plus 2/3 pi r cubed. So we're probably going to need this in a minute. Let's go for the surface area now. So the surface area is, so we've got one circle, so 1 pi r squared. We've got the curved part of the cylinder, which is 2 pi r times h. 2 pi r, so the circumference of the circle, times h. So that's the curved bit, circumference of the circle times h. And half a sphere is going to be 2 pi r squared. So we have, well, we've got 3 pi r squareds plus 2 pi r h. And so we need to eliminate the h, and we're going to use our volume formula to do that. So let's rearrange our volume formula to make h the subject. So take 2/3 pi r cubed away from both sides. So we've got 6 minus 2/3 pi r cubed. Is equal 6 minus 2/3 pi r cubed is equal to pi r squared h. But then to get h by itself, we're dividing by pi r squared. Should I get rid of this fraction first? I'm going to get rid of the fraction first. So I'm going to multiply everything by 3. Each term here by 3. So 18 minus 2 pi r cubed equals 3 pi r squared h. Now I'm going to divide both sides by 3 pi r squared to get h by itself. So divide by 3 pi r squareds, and that's h by itself. So now I can substitute this into my surface area. So my surface area is 3 pi r squareds plus 2 pi r h. So my surface area is 3 pi r squareds plus 2 pi r h. 3 pi r squareds plus 2 pi r h. So I'm going to substitute my h in now. So I've got 3 pi r squareds plus 2 pi r times this. So 18 minus 2 pi r cubed over 3 pi r squared. So let's simplify this. So 3 pi r squareds plus 2 pi r's times 18 minus 2 pi r cubed over 3 pi r squared. So we'll divide top and bottom by pi and divide top and bottom by r, which leaves me with 3 pi r squared plus 2 into this. Let's expand the brackets as we go. So 2 18s are 36 minus 4 pi r cubed over 3r. Where do we want to get to? We want 12 over r plus 5/3 pi r squared. So let's divide both of these terms by 3r. So split this up into two different fractions. So 36 over 3r minus 4 pi r cubed over 3r. And then I can divide top and bottom by r on this one. I'll leave it for now. So I'll go 3 pi r squared. Divide top and bottom by 3 on here. So that's 12 over r. And divide top and bottom by r here. So 4 pi r squared over 3. So this is the same as 4/3 pi r squared. So I've got 3 pi r squared minus 4/3 pi r squared plus 12 over r. 3 of something, take away 4/3 of something. So 3 is 9/3. So 9/3 take away 4/3 is 5/3. So 5/3 pi r squared plus 12 over r. And hopefully that's what we wanted. 5/3 pi r squared plus 12 over r. which is what we wanted. So the manufacturer needs to minimize the surface area of the tank. Use calculus to find the radius of the tank for which the surface area is at a minimum. So this is our surface area. Let's call it A. So it's 5/3 pi r squared plus 12r to the power of -1. So we'll differentiate this. So to find the minimum point, we'll do dA dr. So we're timesing by the power, then taking 1 off the power. So 10/3 pi r minus 12r to the power of -2. And the minimum is going to be where dA dr equals 0. So where is this equal to 0? So 10/3 pi r, 10/3 pi r minus 12 r to the power of -2 equals 0. So I'm going to rewrite 12r to the power of -2 as 12 over r squared. Then I can multiply through by r squared. So I have 10/3 pi r cubed minus 12 equals 0. Multiply by 3. So 10 pi r cubed minus 36 equals 0. Now let's get r by itself. So plus 36 to both sides. Divide by 10 pi. And then cube root. So r is going to be the cube root of 36 over 10 pi. So we want the cube root of 36 over 10 pi. And we've got 1.046. It doesn't say a number of significant figures or anything. So 1.046, and it's in meters. I'll store that as A. Might need that in a minute. So calculate the minimum surface area of the tank given your answer to the nearest integer. So we're going to use that answer and we're going to substitute it into our surface area, which was here. So 12 over answer plus 5/3 pi times the answer squared. So we've got 17. So it was 12 over our answer plus 5/3 pi answer squared. Plus 5/3 pi answer squared. And that was 17 meters squared to the nearest integer. Question 14. So use the substitution u equals 4 minus root h to show that the integral of, well, we've got dh over 4 minus root h is equal to this. So it's been given to us in an unusual format. We've got dh on top, usually comes after. So I'm going to rewrite it as 1 over 4 minus root h dh. We're using a u substitution, and we're told u is 4 minus root h. So we're going to integrate with respect to u. So we're going to write dh du du. So we're going to change 4 minus root h to u. So 1 over u times dh du du. So we need to work out dh du, and then we can integrate. So how are we going to get dh du? We can rearrange this. So make h the subject. So add root h to both sides. Subtract u from both sides. And then square both sides. So h is 4 minus u squared. dh du is this differentiated. So times by the power, take 1 off the power, and then times by the bracket differentiated, which will give us a -1. So times by -1, so it becomes negative. So we've got dh du, so we can substitute that in. So we've got 1 over u times -2 times 4 minus u with respect to u. We can tidy this up, so if we expand this bracket and write it on the top. So let's think of this as over 1, and we're timesing the fractions. So 1 times -2 times 4 minus u. So -2 times 4 is -8. -2 times a negative u is plus 2u. U times 1 is u du. So we're going to integrate this. We're going to split it into 2 fractions first. So let's have -8 over u plus 2u over u, which is just 2. And now we can integrate. So we're integrating -8 over u plus 2 with respect to u. So -8 over u, integrating a 1 over goes to a ln. So it's -8 ln u, and 2 integrated becomes 2u, and then we plus c. So now we can just substitute our h back in for u, so 4 minus root h. So substitute 4 minus root h back in, plus 2 times 4 minus root h plus c. So we've got -8 ln 4 minus root h plus 8 minus 2 root h plus c. How do we want our answer? So -8 ln 4 minus root h minus 2 root h plus k. So they've changed. Plus 8 plus c they've changed this into k, so minus 8 ln 4 minus root h minus 2 root h plus a k. And that's what we wanted. So a team of scientists is studying a species of slow-growing tree. The rate of change, so dH/dt, in height of the tree is modeled by the differential equation given to us. So dH/dt is t to the power of 0.25 times 4 minus root h all over 20, where h is the height in meters and t is the time in years after the tree is planted. So according to the model, what's the range of heights? So this is the rate of change of the tree, and we can say that it's positive as long as this bracket is positive. So t to the power of 0.25 is always positive. 20 is a positive constant. So as long as this is positive, it's going up in height. So, well, it's going to be 0. The rate of change will be 0. So it'll be its maximum height when 4 minus root h is worth 0. And that's when h is 16. So it's going to be going up. It's going to be positive all the way up to when h is 16. And then when h gets bigger than 16, it'll be negative. That would be the tree getting smaller. So that doesn't really make much sense. Trees don't really get smaller. But so it's only going to increase up until 16 meters. So 4 minus root h is going to be bigger than 0. So let's... 4 minus root h has got to be bigger than 0. So add root h to both sides, and then square both sides. H is less than 16. So I think we can say that 16 meters is the maximum height of the tree. So it's between 0 and 16 meters tall. There's no reason it can't be 0. Yep, so let's go with that. One of these trees is 1 meter high when it's first planted. So T is 0, H is 1. Calculate the time this tree would take to reach a H of 12 meters. Give your answer to 3 significant figures. So we're going to be using our part A here. You can see that there's a similarity between these two. So let's write this out. dH/dt is equal to t to the power of 0.25 times 4 minus root h over 20. So it's a differential equation. We're going to get the t's on one side, the h's on the other side. And we know we've already integrated 1 over 4 minus root h. So let's have dh over 4 minus root h equals to t to the power of 0.25 over 20 dt. So I've brought the dt over to this side and divided both sides by 4 minus root h. And we're going to integrate both sides. We've already integrated this left side. So we already know that. That was our negative 8 ln 4 minus root h and so on. So negative 8 ln 4 minus root h, ln or ln, say either one, minus 2 root h plus a k, I can plus a c to either side, so equals, so this is like 1/20th t to the power of 0.25. We're going to add 1 to the power, so t to the power of 1.25, and then divide by the new power. So a 20th divided by 1.25, I'm going to put it in the calculator, divided by 1.25, it's a 25th, and then plus c. So we can use our information given, t is 0 when h is 1, to find c. So t is 0 when h is 1. So substitute in h is 1 and t is 0 and find c. So minus 8 ln 4 minus 1, so 3, minus 2 times 1, 2, equals 1/25th, well, of 0, so 0 to the power of 1.25 is 0, times 1/25th is 0, so that's c. So we've found c, so we now have minus 8 ln 4 minus root h, the mod of 4 minus root h, minus 2 root h equals 1/25th t to the power of 1.25 minus 8 ln 3 minus 2. And for the final part, we need to substitute in h is 12 and find t. So substituting h is 12 to find t. So let's substitute in h is 12. We're going to get a decimal out, but 3 significant figures, that's okay. So let's substitute in h is 12 into this. So it's going to be minus 8 ln 4 minus root 12 minus 2 root 12 equals 1/25th t to the power of 1.25 minus 8 ln 3 minus 2. So let's type in this left side, minus 8 ln 4 minus root 12. This is going to be positive, so we don't have to worry about that. Minus 2 root 12. So we've got negative 1.937. When I said it's going to be positive, I just meant this the bit in the mod. So negative 1.9377. I'll store that. Negative 1.9377 equals 1/25th t to the power of 1.25 minus 8 ln 3 minus 2. So let's add these on. So add the 8 ln 3 and the 2. So we've got our answer. Add 8 ln 3 and add 2. So we're adding 8 ln 3 to both sides and adding 2 to both sides. So 8.85 we've got now equals 1/25 of t to the power of 1.25. Now multiply both sides by 25. So times 25. So 221.3 equals t to the power of 1.25. Then we need to, well, find the 1.25 root of both sides. So it's our root button. So the 1.25 root of our answer, which is hopefully still there, and that's 75. Did it want it to 3 significant figures? So that's t is 75.2 years.